Here we have another sequence and series problems. Remember, a sequence is a set of numbers. A series is adding up those numbers. Here we want to know the sum of the first 15 terms, where the first term is -2, the third term is 7. This is a little bit more complicated. So what we have here, if I'm going to draw this out here for you, here's the first term, -2. And then we're going to have a blank term, which we don't know what it is. And then we're going to have the next term, which is 7. And then we're going to keep going. So those are the terms here. Obviously, the difference between this and this is 9. But that difference is going to have to be divided up between that and that. We're going to have a d here and a d here. So we're going to have d twice to make up for this 9, which means d is going to be equal to 4.5, 4.5. I'm going to write this in here with a different color. Now we've got the basic stuff that we need. We have our first term, we have our d, we have our number of terms. We can add them up. We've got two different formulas for adding up arithmetic sequences and series, for adding them up, because they're series when we add them up. I'm going to write them up here for you. The first one is pretty straightforward. S and n is equal to the number of terms times the first term plus the last term divided by 2. This is a pretty straightforward equation. This is like an average of all the terms. So you have a bunch of terms, the first one, last one, this one puts you right in the middle. And you're adding up the number of terms you have by the average, which sort of gives you the sum. It makes sense. It's a fairly easy thing for you to illustrate for yourself. I've done this in another video. The other equation for the sum is this. The sum is equal to n over 2, big brackets, times 2a plus n minus 1 d, like that. This looks a lot more confusing. You won't be using this as often. If it's given to you, if you have the number of terms and the difference of terms, then you can use this one here, or you can find a way to find the last term, because you have n and you have d. You can find the last term and use this one. If you notice this here, if you took an a out of this and you made this a plus this one here, this really is an equation for the nth term. And this is the first term. So these things in here are really the first term plus the last term times n divided by 2. Exactly what this is. It's just a longer, more convoluted form. I'm going to erase this here for a second and just use this thing here to calculate the sum. Well, we don't have the last term. We have the first term. Let's see if we can find the last term. So t of 15 is equal to -2 plus n minus 1 times the difference of squares, the difference. So -2 plus n minus 1 would be 14 times d. We found that out to be 4.5. I am getting this equal to 61. This is the 15th term. It's not the answer that we're looking for yet, but now we can use this equation here. So I'm going to write down T15 is 61. The sum is 15 numbers. 15 times the first term, we're given that, -2, plus the last term, all over 2. This would be 59, so that's 15 times 59 over 2, 442.5. That would be the sum. It seems reasonable. Let's check here. It's one of the answers. We could use the other equation as well. We're sort of duplicating what we do here. So I'm going to erase this and get to another one really quickly.